Good morning, class. So today we're going to do part 2 of the 6-5 lesson. And just like last lesson, there's 2 steps. We have to isolate the radical, and we have to raise both sides to the same power. It's got to be the power that undoes that radical. There's actually one extra little thing we're going to have to do today, and we're going to have to check the answers. So then check answers. See, the difference between last class's lesson and this lesson is that there's a variable on the other side. So not only is there a variable under the radical, which makes it a radical equation, there's also a variable on the other side that's outside of the radical. So because of that, we're going to need to check our answers and make sure we don't get something called an extraneous solution. All right, so let's start. Just like yesterday, we have to isolate this radical. So here's our radical. To get that by itself, we're going to move the 5 over. So I'm going to add 5, add 5. You can't actually add this, so we're just going to write x plus 5. So over here on this side, we have square root x plus 7. And over here, we have x plus 5. Okay, this x is still in a radical. So we have to get rid of the radical. We have to raise both sides to a power. So since that is a square root, I'm going to raise it to the second power. That's how you get rid of a square root. All right, here's what made this part 2 a little bit more complicated. Oops. We're squaring this binomial. So it's not just x squared plus 5 squared. We have to square this binomial, which we'll talk about. Okay, the square root and the square, they undo each other. They're gone. So we have x plus 7. This is where it gets a little complicated. Okay, here's what this means. This means x plus 5 times x plus 5. So to square that, we have to FOIL it. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. And so then, combining like terms, these two guys can be combined. X squared plus 10x's plus 25. So that's what's over here on this side. X squared plus 10x's plus 25. All right, so here's what my equation looks like now. Well, we've got an x squared and we've got an x. That means this is a quadratic. To solve a quadratic, one side has to be 0. I do not like to move my x squared to make it negative. I like x squared to stay positive. So wherever the x squared is, that's what I'm moving to. So I'm going to subtract x. You have 7 equals x squared plus 9x plus 25. And then remember, we're trying to get 0, so I'm also going to move the 7. And you get this. You get 0 equals x squared plus 9x's plus, that gives you 18. Now, that's a quadratic that equals 0. So it takes you back to chapter 5, where we did a whole chapter on solving quadratics. To solve that thing, I'm going to try to factor it. It may not factor, and if it doesn't factor, then we're going to need to use the quadratic formula. So I'm going to try to factor this thing. I want to do this. It's not always possible. Okay, so over here, I'm going to break down the 18. So for this lesson, you may want that chart that has all the numbers from 1 to 100 all broken down for you. That factor chart from Miss Stacy's class. All right, so it looks like that. Did I miss any? Nope. 5, 6, yep. Okay, so I have to choose the ones that multiply to be 18 and add to be 9, and that would be 3 and 6. So x plus 3, x plus 6. Since none of them have numbers in the front, you can, if you remember, you can just go straight to the solutions. The opposite of positive 3 would be negative 3. The opposite of positive 6 would be negative 6. And so let me show you over here, just remind you how we got that. You set each of these factors equal to 0. X plus 3 equals 0. and x plus 6 equals 0, and then you're solving. X is negative 3, x is negative 6. So that's how we got these answers. Okay, it's possible in problems like this that you get something called extraneous solutions, which means we did all this work, everything's correct, we got these answers, but they may not work in the original problem. So I'm going to take negative 3 and plug it in both x places, and I'm going to take negative 6 and plug it in both x places to make sure they're not extraneous. You only have to do that when you have an x in the radical and x out of the radical. So we didn't have to do this last class. Negative 3 plus 7 minus 5 equals negative 3. This is square root of 4 minus 5 equals negative 3. That's 2 minus 5 equals negative 3. Negative 3 equals negative 3. That solution is good. And then when I plug in a negative 6 in there, square root negative 6 plus 7 minus 5 equals negative 6. So I'm putting x in both places, right there and right there. And you get square root of 1 minus 5 equals negative 6. Square root of 1 is 1. You get negative 4 equals negative 6, and that's not true. So negative 6 is called an extraneous solution, which means the only solution to this problem is negative 3. All right, example 2. So remember, a half power means square root. So this is a square root. It looks a little different than the last problem because on the last problem, the x was over there on the right. Well, here, the x is over here with this radical. So remember, it says isolate the radical. So here's our radical right here. We have to isolate it, so we have to add the x. And we get this. We get 2x minus 1 to the 1/2 equals x. So now it looks like this problem. Looks just like it. So if you want to pause the video and try it, then you can do that and then press play and you'll see me work it out. Now it does look a little different just because of this radical. The radical was written to the half power instead of square root. But this means square root of this stuff. So I'm going to square it. That's how you get rid of this square root. Or in other words, to get rid of a 1/2, we're multiplying it by 2 over 1. So you get that. Okay, over here, the half and the 2, half times 2 is 1, or in other words, they cancel, half times 2. And you have 2x minus 1 equals x squared. The good news is we don't have to FOIL this. So now I'm going to move these over there with the x squared. See, I don't like to move the x squared to this side because it would become negative. It's hard to factor when the x squared is negative. So I'm going to move the 2x over. Remember, you can't actually add it to this. You're just going to write it over there with it. That's gone. And I'm going to move the 1. So I'm going to add 1. Remember, you can't actually add it, so you're just writing it. And now you have nothing on that side. We want one side to be 0. And none of this can be added. I'm just going to bring it down. X squared minus the 2x's plus the 1. Looks like that. And now we've got ourselves a quadratic. I'm going to try to factor it. Now, remember, it's possible this thing, once you get to this step, it's possible to get something that doesn't factor. And if that's the case, you can still solve it using the quadratic formula. All right, so factors of 1. 1 times 1. All right, those are the only way to get a 1, right? Although it's positive, so it's possible that they're both negative. And here's why I thought about that. Because I'm trying to get a negative 2 in the middle. And 1 times 1 will give you 1, but 1 plus 1 gives you positive 2, and that's a negative. So these need to be negative. They still multiply to be positive 1, but they add to be that negative 2 in the middle. So your answers in here, your factors are x minus 1 and x minus 1. Looks like that. And so if you set this equal to 0, you get 1. If you set this equal to 0, you get that same answer. So x is 1. You don't have to write it twice. If you do, that's not wrong, but you don't have to. I would plug it into this original just to make sure it works, because it is possible that the only solution we found is extraneous. So 2 times 1 minus 1 raised to the half minus 1, I'm just plugging in 1 everywhere I see an x, equals 0. And I need to check this. 2 times 1 is 2. 2 minus 1 is 1. So that's 1 to the 1/2 minus 1 equals 0. This means square root of 1. Well, square root of 1 is 1. And 1 minus 1 is 0. So it worked. So our one solution is a good solution. It's not extraneous. It works. All right, one more example today. These notes are weird because I started out with the hardest problem, and then this one was a little bit easier because we didn't have to FOIL that. And then this one, it looks complicated, but this is the easiest one yet. All right, so see how there's a square root here minus another square root? Well, the directions are isolate the radical. So we're gonna take this first, we're gonna get this first radical by itself, which means we're gonna move that whole thing to the other side. We're gonna add this big ugly thing right here. Add the big ugly thing. And that's gonna cancel from that side. So what we have is x minus 2 raised to the 1/2 equals 2x minus 7 raised to the 1/2. Like that. Okay. So step 1 is isolate the radical. So we got this first radical by itself. And what we have is a square root equals a square root. So now we're going to do step 2, and that is to raise both sides to the same power. So the power we're going to raise it to is the second power, because this means square root. To get rid of square root, we raise it to the second power, raise to the second power. And the cool thing is, it cancels on both sides. Half of 2 is 1, so that cancels. Half of 2 is 1. When you raise to the 1 power, it's just that same base. So x minus 2 equals 2x minus 7. So see, it basically just dropped the radicals. It dropped all that fractional power mess, and it's just a normal equation now. This is not a quadratic, so it's just regular combining like terms, get your x's together. So this would be a good place to stop the video, solve that, and then just check to see that you get it right. But I'm going to subtract x. You get negative 2 equals x minus 7, and then the last step is to add 7. And you get 5. 5 equals x. And I would plug that in to make sure. So 5 minus 2 raised to the 1/2 minus 2 times 5 minus 7 raised to the 1/2 equals 0. This is 5 minus 2, which is 3 raised to the 1/2, minus, this is 10 minus 7. 2 times 5 is 10, minus 3 to the 1/2 equals 0. Now the reason I didn't evaluate that is because square root of 3 is just gross. But you can see that whenever you have something minus itself, you're getting 0, so that works. All right, so that is all for today's lesson, and you have some homework on that. And I hope you guys have a great day. I am missing you terribly, but all is well here, and I hope all is well with you. So y'all have a great day.